What are you trying to teach yourself about right now, Neb?
A lot of physics stuff. I'm jumping around a lot between different topics. So quantum field theory is the main thing. I ran into problems where relativity is a prerequisite. I know it in popular science terms, but I don't know the math behind it.
Gotcha.
So I started picking up a textbook on the math behind it, and I'm going through that now. But I'm also struggling on it because now I'm realizing I don't know calculus as well as the author expects. The thing is, I passed calculus, but I didn't use it, so I lose it. I lost it.
Right.
And so when you say, what's the derivative of this? I have to go look it up. I don't remember.
Right. I remember that derivative is related to calculus in some way. Is that helpful?
I feel like this author skips steps also, which annoys me. It's typical in math texts to write multiple lines one after the other, and they're all equal to each other, right? I don't know if you're familiar with this. So there'll be a line where I say, like, how do you get from this line to this next line? They're doing something, like multiplying both sides by x or something, but I don't know what they're doing. I'm like, how do you get from here to here? So that's what I mean by skipping some steps. It's not obvious to me. The author is asserting these two are equal, and I'm not seeing it. How did you get from this equation to this equation?
Yeah. It sounds frustrating what you're describing.
Yeah, I have an example I think that I can find real quick, hopefully. So events are points in space-time. Choose inertial coordinates such that the straight trajectory describes a motionless particle event A located these coordinates t and x 0, 0, c located delta t 0. The two paths then describe an isosceles triangle in space-time. B has coordinates 1/2 delta t 0, blah, blah, blah. Clearly, I love it when they say that. Clearly, delta tau AB equals 1/2 delta t, but delta tau AB prime equals this, which, so up until now, just take it on faith, right? He's like this. But now, from here, I'm like, wait, how is this equal to this? I notated this. Here's line 1, here's line 2. How is line 1 equal line 2? And it took me a day to figure it out. Like, I saw this, I put it down, I came back the next day, and I was like, oh, I see now.
Sure, obviously.
You could have done it more explicitly. Do you want to try to figure it out, or you want me to just tell you the solution?
No, I don't. Like, you take out the half, you...
Yeah, but you can't just take half out of a square root. It won't be equal, right? Because there's a half here, but then there's a minus here. So if you take a half out here, you have to take out a half from here somehow?
Right, because the triangle x equals 1/2 of v triangle t.
Yeah,
and so you can
substitute
that.
Yeah, that's what I was missing. You got it right away. I'm looking here, dude. Like, okay, you know, what if I like?
I can't understand it at all.
Well, I was saying, like, I'm just gonna cross multiply it out, right? Like, I'm gonna say like 1/4 over delta t squared minus delta x squared.
Right, you understand it enough and then, like, to try and do it, which screwed you up.
Yeah, but then I was, oh, you just take this substitute in. So that's a missing step. Like, you should just have an intermediate step here where he literally says 1/2 delta t squared minus 1/2 v delta t squared. Like, you know, take this. Right. And then from there, then you can get to here. And I was like, oh, there you go. The other thing is, I don't know if this is cognitive decline, but I'm struggling to remember what all the symbols mean when I'm reading these formulas.
No, I think it's just lack of practice using them, right?
I feel like in the past, again, it's difficult for me to know, is this cognitive decline or is this topic too far out of my level? Like, when I was in high school, they're introducing new symbols all the time. There's a first time you encounter sine and cosine, for example. There's a first time you encounter fractions. And I felt like I was just like, yeah, you tell it to me once and I got it, right? The thing is now, I don't want to insult you, Steph, but I don't know what your math familiarity is, so I'm going to maybe over-explain, and maybe that's fine because it might help the viewers as well. But when you like add things together or you multiply things together, you can think of adding two integers together and then adding like two fractions together. It's a slightly different operation, right? You have to do slightly different things when you're doing that. Like, maybe for fractions, you have to make sure they have the same base, for example, first before you add them together, right?
Yeah.
So getting a bit more advanced than that, there's things called like vectors and matrices. And then there's rules for how you add those together, which is a little bit more complicated than just adding normal numbers together. So he'll have this equation, the author of the book, and I'll be looking at the symbols in the equation, and I can't remember, is this a vector or is this a scalar? Scalar is another word for normal number, basically. And so what do I do when I'm multiplying these together? Because it's different if it's a scalar versus if it's a vector.
Yeah.
And I can't remember, like, I think what the symbol, like,
it's not really designed for someone to just... Yeah, I'm guessing it's a pedagogical issue. Like, I'm guessing it's not a very well-written textbook, or it's a textbook that really needs to be reinforced by doing the exercises a little bit more slowly together in class or something like that.
Yeah. Well, that's the thing. I'm trying to do it slowly. Like when I got to the equation we just looked at, right? It's very convenient to say, the author says clearly this, right? And you're like, okay, and then you move on, right? But I'm like, wait, is this true? Let me see. And then I try to follow it and I get stuck because I say, it's not true. How did this V get out of nowhere? So I feel like I am going at it slowly. But I feel like it's just too much working memory needed. Like I can't remember.
Yeah.
Like there'll be like 7 or 8 symbols in the equation. What does each symbol mean? I have to remember that. I have to hold it in my head while looking at the equation.
Yeah. And depression does directly affect working memory too, so there could be some of that.
The other thing, I'm not sure if this is a Sapir-Whorf thing or something different but related, but if you don't know how to pronounce a word, I feel like it's harder to remember it.
Yeah, agreed.
So for example, there's probably a psychology test where it says, here's a list of words like cat, snowman, umbrella, and so on, and you just have to memorize it. There's no real semantic meaning from it. You just memorize a list of words and then you repeat back. And most people can do okay at that. Like maybe they can remember a list of 10 words or 12 words or something like that.
Okay.
But if you show like, now memorize these Chinese characters, assuming you don't read Chinese.
Yeah.
Just memorize 3 characters. Just 3. That's
Right.
all. Not even 12.
Yeah.
There's no semantic content. That's the same, right? But it's like super impossible.
It is, yeah. It's because you can chunk things that are familiar. And so then you can remember like 7 things, but if you can't chunk, you can really only remember like 3 to 4.
But I don't know
And
if
if you're not
it's...
familiar with it, you can't chunk.
Well, that doesn't seem to be what the cause is. Because here I'm saying with English words, you can memorize like maybe 12 of them, right? I think it's reasonable to, if you really focus it hard, you see a list of 12 words, and then you're given a list of 50 words, and you circle which 12 words were in the original list. And I think people could do that, like a typical person could do that.
Mm-hmm.
But if you're given not 12, but now just 3 Chinese words, and then now here's a list of 10 Chinese words, circle the ones that were in the original.
Yes.
I guess maybe it's chunking in the sense of without chunking, because you don't have the semantics, what you have to do is you have to memorize each individual stroke, each line.
Right, exactly. I was just going to explain why that's chunking.
Whereas you're chunking it as a word if you knew the word, if you could read it. And you say, oh, that's a word for dog. I'll just remember dog instead of remembering the 4 or 5 lines that...
Exactly. So like you can memorize the word, and I'm using it in air quotes that you can't see, but the word FBI, right? And so if I say, hey, remember FBI, JFK, NASA, CIA, right? To you, that's only 4 things, even though it's 13 letters.
Yeah.
If I gave you 13 letters, you're going to be like, you've exceeded my capacity.
Right.
And so when you chunk it as a word, you're chunking it. Whereas a Chinese character, like you said, it's however many strokes. And not only the stroke, but you got to remember the angle that it's at and how it's related to another thing. And each of those is sort of like a letter, even though it doesn't explicitly look like a letter on the page.
Yeah.
It's an aspect of what you're trying to memorize.
Because like, and let me open up that image again. So you call this triangle, right? But I know it's delta because this symbol comes up a lot in basic physics. But there's other symbols,
right.
Like this is tau, which I don't expect people to know that one. Both delta and tau are Greek letters.
Right.
And if you don't know that, I think it's pretty hard to keep in your head the difference between, because this looks like T, and tau is basically the Greek T. And then you look at this delta T
like
versus delta tau, right? Don't get them mixed up because you're going to get fucked up if you mix up your delta taus and your delta Ts.
Yeah, that's a problem. But I'm reading it as triangle tab, which is worse.
Yeah.
And I have trouble all the time with things like that tau versus T. My brain refuses to pay attention to stuff like that.
Yeah, you are going to get real fucked up. Because the thing is, the way he uses it, it doesn't say it in this paragraph, but I know from reading the rest of the book, he's using tau whenever he's talking about proper time, which is time as experienced by a person or a particle moving through space. Whereas he's using T for coordinate time. So if you have an imaginary clock at rest at that point, what time does that clock read? And so the idea is if you're moving closer to the speed of light, your time is moving slower for you. versus someone at
I'm
rest.
literally already so annoyed.
So it's different
Yeah,
and it's important. You have to differentiate
yeah.
between delta t and
No,
delta tau,
no, thank you.
or
Do
else you're
not
gonna
want
get
to.
everything wrong.
Nope. Yeah.
And the other thing is you have to realize that there's a prime here, and prime is a common convention in physics to mark as an alternative to something. And in this case, what he's saying is there's two paths from point A to point B, and there's a different point called B prime. So what's the delta tau from A to B, like if you go along this path, versus what's the tau from delta A to B prime, where if you take a different path, you're going to experience a different amount of time passing, is what he's trying to get at. But when you look at this symbol down here, the delta tau A
Yeah.
B prime, you have to understand that the prime is to
Yeah.
the B, right? Like it's a
Right.
different B, a different
Not the
destination.
triangle pad.
Yeah,
The
exactly.
triangle
Not the
pad
delta
prime.
tau is being prime, not a
Right.
different duration, but a different destination. And so
Oh,
in this one, I can
Mario
understand
Kart.
it, right? But in the other example, I don't know
Right.
if I can find the example now because I don't have the PDF readily available to me. But it's like all these Greek letters, 12 Greek letters in a row with subscripts, superscripts. Like these
Oh,
are the subscripts, right? A, B. And I'm like, which subscript goes with which letter? What cluster? Like when you see a prime, is it on the B or is it on the tau? And I think if I had more working memory, I could figure it out. Like I think he tells you, but I
maybe.
can't hold it in my head all at the same
Yeah.
time while
Oh,
understanding
thank you.
the equation. And that's why I'm trying to figure out like, could I have done this when I was younger? Am I having cognitive decline? Or is it like this material is just harder than any other material I've done before? And so even younger, I would not have been able to do it. And I'm just gonna have to put more work, I guess, you know?
I think you would have had a lot of support in the form of other readings, discussing it in lecture, your peers also learning it. It would have been spoken as well as written.
Oh yeah, the spoken thing.
would have
Yeah, so
been-
that's part of it. I was
yeah.
talking about the Chinese thing. He'll use Greek letters. I don't know what those Greek letters are. So I don't know
Right.
how they're pronounced. So now they're the
Right.
Chinese thing. I have to
Yeah.
memorize the shape as opposed to in my internal monologue, I say, oh, that's dog. I'll just memorize dog.
Right.
Or it's delta.
Yeah.
I'll just memorize delta. And so also part of me struggle, like if I get stuck in this equation, should I just move on? Should I just read the prose? Or should I stick with it? Like, no, don't go on until you can actually follow the equation. Because you can do that once or twice, but after a while, you're gonna get completely lost if you just skip over every equation you don't understand.
Yeah, it's tricky. I think the other thing in college, you know you have a test or you are worried about your grade or you think it's going to be important for later classes or you want to show off to potential mates or whatever. And I think when you're trying to teach yourself something later, as much as you try and psych yourself up, you do not have the same number of natural rewards.
Yeah, I feel like most of those things you talked about didn't really affect me, but I'm probably atypical that way. The exception,
Maybe, but I think they probably also affected you subconsciously.
so in high school, for example, I had the habit of doing the homework, but then not handing it in, and then getting 0. So I would do the homework because I want to learn, but I didn't hand it in because I didn't care about the grade.
Right. But something probably was influencing you, right? Like, even if you're just of the age at which you're trying to get status as a teenager.
Yeah, so
you know,
I was
you
gonna say,
kind of
with the
know
exception,
about-
as in
yeah.
none of those things with the exception of impressing a mate, which is still true today, right? I still want to impress mates. I
Right.
still want to learn that stuff.
Right. I mean, it's human motivations, right?
I think the biggest factor is social expectation, and also you're given the time. Like, as a kid, you're in school, and that's all you do.
That's what you're doing, exactly. Your peers are modeling, that's what we're doing, yeah.
Whereas now, I'm like,
You don't have a job or
I have to,
other
set
things
aside
to focus
time.
on. Yeah.
Because
Yeah.
I can be filing my taxes, or I can be
Right.
reading this PDF on special relativity. And sometimes there's the question of, am I wasting my time? What am I doing here?